This video is a part 2 of this converting a quadratic function from standard to vertex form by completing the square. In part 1 we mainly concentrated on understanding what is this completing square, what is a perfect square trinomial, how to get that perfect square trinomial, etc. We discussed in the part 1 of this video. Please watch it if you did not. Now, in the second part, we are going to complete our learning of changing a quadratic function from standard form to vertex form. Right? Given ax square plus bx plus c, we have to change it into the form of a times x minus h whole square plus k. And in this h comma k is the vertex. The vertex h comma k. The x coordinate is h and the y coordinate is k. That is vertex. We are going to look at it as we move on. Alright. Now in this, first we have I can say that the whole procedure step by step it is explained here. Let us do one step at a time. The steps for completing the square of a quadratic function f of x is equal to x square plus bx plus c. Right. Earlier I showed you with the known process of factorization, but here we are doing the actual procedure, like how it can be done one step at a time. Now we have the function f of x is equal to x square plus bx plus c. In the first step, I have to group the x square and x terms. So in that f of x is equal to x square. In this case, we have a is 1. There is a known number, no numerical value, that a is not given to us, so just we take that a is equal to 1. So x square plus bx plus c. So in this, group the x square term and x term. So we can put those two things together. You know the properties, associative property. So in the second step, take half the coefficient of the x term and square. So the x term is bx here. Bx is there, that is the x term. But you are looking for only the coefficient, that is b. This coefficient b is divided by 2. So b over 2. I took the half and then square it. So on squaring, b over 2 square gives me b over, that is b over 2 times b over 2 gives you b times b square over 2 times 2, that is 4. Or directly you can write b squared over 4. Now add and subtract this b square over 4 to the given function, to this value. So what happens here? F of x is equal to x square plus bx plus, I'm adding b square over 4. So what I got in the second step, I have to add and subtract in the third step. So that is b squared over 4. So I got it here. Plus c is already there given to me. Then I'll minus b square minus b square over 4. Okay, see it here again, this piece, b squared over 4 is added and subtracted. So to any given expression, we can add and subtract the same quantity without changing the value of the function. We should not change the value of the given function, but we can only just manipulate without without changing anything over there. Like the whole value has to remain same. So whatever we introduce, we should take it away. I added here b square over 4. So I'm taking away b square over 4. So we are good in step 3. Now step 4, factor the quadratic trinomial as a perfect square. This is where the first part of the video helps you. Now this is x square. I'm looking at the first 3 terms. X square plus bx plus b square over 4. Okay, that becomes f of x is equal to, from x square, this formula I'm using, a square plus 2ab plus b square gives me a plus b whole square. So this expression is satisfying that condition. X square here, so I got x plus b square over 4. Its square root is nothing but b over 2. That is b over 2 whole square. Right? The first 3 terms gives you that. And then plus c minus b square over 4. So from step 3, it is transformed into x plus b over 2 whole square plus c minus b square over 4. This is like the vertex form of a quadratic function. We are going to look at an example instead of a, b's and c's. You'll understand it better. Now simplify if possible. We are looking at this c minus b square over 4, c minus b squared over 4. Further, you can simplify and write it as 4c minus b square over 4, or you can just leave it as it is. Right? So what are our 5 steps to change a quadratic function from standard to vertex form? In the first step, you group those two together, the x square and x term, and then take the half of this b over 2, then square, and whatever you get here, that is added and subtracted. And after that, making use of this perfect square trinomial, you got x plus b over 2 whole square plus c minus b square over 4. Right? And the 5th step, you can just simplify those 2 numbers, you can put them together. That's what it is. Now let us see, look at one numerical example for better understanding. We have x square plus 16x plus 7t. Alright, that is f of x is equal to x square plus 16x plus 7t. Then group the x square term and x term. I did that. Now take half the coefficient of x term. The x term is that 16x. In this 16x, 16 is the coefficient. The numerical value is 16. I'll divide by 2 because I have to halve that, so divide by 2. 16 over 2 gives me 8. And 8 on squaring, you're asked to square it, right? So 8 squared is 8 times 8 gives you 64. Then add and subtract this 64 to the given function f of x. So f of x is equal to x square plus 16x plus 64. I am adding 64 right after the second term. Then already I have 70 given to me in the problem. But in this process, I added 64. That is, we have introduced 64 into the function. So take it away. That is what it is said here. Add and subtract. That same number 64 you should add and subtract. Then what happened? Factor the quadratic trinomial as a perfect square. So f of x is equal to this first three terms, x square plus 16x plus 64. It is just like the perfect square trinomial a square plus 2ab plus b square, x square. The last term is 8 square. So in the middle I have 2 times x times 8. 2 times 8, 16. 16 times x is 16x. So it becomes x plus 8 whole square. Alright, you can even see it this way. You have 16, this is 16, that is 64, half of that is 8 and 8, right? 8 plus 8, 16, 8 times 8, 64. So your factors are x plus 8 times x plus 8. Alright. So I will write x plus 8 whole square. So we handled these three terms. Plus 70 minus 64. That's 70 minus 64. 70 minus 64, simplify if possible, means it is this. 70 minus 64 is equal to 6. Hence, your function, this function f of x, or the given function f of x equal to, what do you have here? This one. Let me see here. F of x equal to x square plus 16x plus 70 changes to what? X plus 8 whole square, and 70 minus 64 is 6. This is the changed or transformed form of the given function. From they gave it to us in the standard form, we changed it into vertex form. Alright. What are the steps? Very simple. Group these two together, x square plus 16x. Half of 16 is 8. 8 square 64. Add 64. Subtract 64. And then I have to know this. How do you convert this perfect square trinomial into this product form as x plus 8 whole square? You can do this way, or whatever process you apply, you'll get this x plus 8 whole square plus 6. Okay, now let us look at one or two examples. The first one here, you have f of x is equal to x square plus 14x plus 52. We have to find the vertex and the axis of symmetry. So this is the vertex form of a quadratic function. F of x is equal to a times x minus h whole square plus k. We are looking for the vertex. The vertex is h comma k. H and k. And the axis of symmetry is x equal to h. Okay, so let us follow the steps that we have discussed earlier. Let us see. The first one, I'll group this first and second terms together. So f of x is equal to x squared plus 14x plus, I'll even leave some space here because you know you have to get that third term here, plus 52. Now in the next step I have to divide this 14 by 2. What is half of 14? That gives me 7, and a 7 on squaring will give you 49. 7 times 7 is 49. So that 49 I'll add here. The space I left 49. So because I added 49 to this expression f of x, the same 49 I should take it away. So adding and subtracting 49. 49 is added and subtracted. Good. Now this x squared plus 14x plus 49 now changes to x plus 7 whole square. You know why? Because this is x square and 49 is 7 square, and in the middle you have 2 times x times 7, right? So x plus 7 whole square, or following that same old process, my 14 here, 49 is the product. My two numbers, they have to be 7 and 7, so that my product is x plus 7 times x plus 7 gives me x plus 7 whole square. Any method is fine. So f of x is equal to x plus 7 whole square plus, I have to simplify this if possible, 52 minus 49. That is, take away 49 from 52 to give you 3. Right? So this function f of x equal x square plus 14x plus 52 is changed to x plus 7 whole square plus 3. We are not done yet. You are looking for the vertex and the axis of symmetry. So this is the formula for vertex form of a quadratic function, f of x equal to a times x minus h whole square plus k. This is our function is transformed almost into the vertex form, except this plus 7 here and there. In the formula I should have a minus. So how can I fix that thing? I will write this as f of x is equal to, even there is no a here, there is no, I can write 1 times x minus, actually I need a positive 7, plus 7. So I'll write x minus negative 7 whole square. So by doing this, I did not change my function. The given problem is not changed. We change that negative times negative gives you a positive value. The product is positive. That's what we did here. Negative of negative 7 gives you positive 7. Now everything is satisfied. The standard, the vertex form of quadratic function. Now this a is equal to 1, x and x are there, minus and minus, and this h is equal to negative 7 and k is equal to 3. So we are saying that h is negative 7 and k is equal to k is equal to 3. So your vertex, using that vertex is h comma k, my vertex is equal to negative 7 comma 3, and axis of symmetry In short, I can say AOS, that is axis of symmetry, is x equal to h. So x is equal to -7. That's all. So very simple process, right? Divide this 14 by 2, square, and then add and subtract that 49, and just put it together. You have it. We are going to look at one more example. Okay, in this case, we have f of x is equal to x square minus 20x plus 95. So these two are together, right? I have to write them together. F of x is equal to x square minus 20x plus, I'll leave some space for the third term, plus 95. Now divide this 20, I can even take -20 divided 2 to give -10. Now I'll square that -10. -10 times -10, -10 times -10 gives you positive 100. That is 100. So I'll write 100 here. 100 is added. Take away 100. Adding and subtracting 100. What next? That becomes f of x is equal to x square minus 20x plus 100. X square minus 20x plus 100. That is x minus 10 whole square, because x square, then 2 times x times 10 is 20x plus 10 square is 100. This is what I'm saying, a square minus 2ab plus b square, using that perfect square trinomial, that is a minus b whole square. Or like I always say, use this process, -20, positive 100, half of -20 is -10, and -10, right? Adding 10 and 10 is -20. Multiply gives you 100. So your factors are x minus 10 times x minus 10, which is x minus 10 whole square. So that's what I'm writing here. X minus 10 whole square. Please remember, this is a perfect square trinomial. To make this as a perfect square trinomial, only you are dividing that to half and then squaring. That is the story. Okay. Now, plus 95 minus 100 is there. These two terms you can combine. From 95, take away 100. That gives you minus 5. Right? 100 is bigger, so that sign I'm taking here. Now, this is in your vertex form. Directly you got your f of x is equal to a times x minus h whole square plus k. Okay, so it's almost in vertex form, let me say that, because I'm seeing plus k and minus 5 there. Let us fix it up. We change this into f of x is equal to, there is nothing here, so I can just write 1 times anything is same, 1 times x, there is a minus 10 whole square, telling me that h equal to 10, plus k I need, so plus -5. So plus of minus gives you minus. Positive times negative is negative. So -5. We didn't change anything. We have rewritten. We simplified for our convenience to give a is equal to 1, h is equal to 10, and k is equal to -5. So your h is 10 k negative 5, that is vertex is 10 comma negative 5, and the axis of symmetry is 10. So going back, it is just the same. No, that's 20. This 20 divide 2 square, and 20 divided is 10. 10 square 100. 100 is added and subtracted. So you got this, and then follow the process. Now last example. Here I have an odd number. That's why we need to be extra careful while dealing with such odd second term. It's not difficult, but just fractions. You'll have to deal with fractions. So f of x is equal to x square plus 13x plus, I leave space for the third term, plus 50. Okay, now the second term, this 13, I have to handle that 13. That is x. Okay. 13 is divided by 2. So it is 13 over 2 only. Or you can write 6.5 in the decimal form. Preferably we will just use fractions. So 13 over 2 is just 13 over 2. Now I want to square this. 13 divide 2 on squaring gives you 13 times 13 is 169, and 2 times 2 gives you 4. So this number has to be added and subtracted. So 169 over 4 is added, and same 169 over 4 is subtracted. Nothing different except fraction. Alright. Now that changes to f of x is equal to x plus this number 13 over 2. That's square, no? So 13 divided 2 square. So this x plus 13 divided 2 whole square is obtained by following the same procedure that we applied earlier, like x square plus 13x plus 169 over 4 is nothing but x square plus 2 times this 13 over 2 times x plus 169 is what? 13 square. 4 is 2 square. This thing. So it is of the form of a square plus 2ab plus b square to give me a plus b whole square. Right? That is, a is your x, a is x, and b is 13 divided 2 whole square. That's what you have here. Or else you can also follow that same old process. This is 13, so half of 13, and here I need what? 169 over 4. Therefore I have 13 over 2. This is also 13 divided 2. Same thing. Add half of 13 plus half of 13 is 1 whole 13. Multiply. This is 169. Okay. On product it will be 169 divided 4. Alright. So that's what you have here. Now plus 50. This thing. 50 minus 169 over 2. How do you simplify that? They said if it is possible we have to simplify. 50 minus 169 over 4. I'm sorry, this is not 2, that's 4. it is 169 over 4. If I added 169 divided 4, I have to subtract the same thing. Whatever you give, you have to take away. Okay, alright. Now, how do you simplify? This is 1 can divide 4 times, that is 200 minus 169. 200 minus 169, I think it is 31 over 4. So here I'll write 31 divide 4. Let us verify using calculator also. Let us just make sure. What is the thing here? 50 minus 169, right? 50 minus 169. I'll go to fraction. Alpha and y equal to, that is 169 over 4. Come out and hit enter. See, you have 31 over 4. That's right. Now, this is in your vertex form. What is my vertex form of a quadratic function? F of x is equal to, we have f of x is equal to a times x minus h whole square plus k. Everything appears same except this plus and minus there, and we already know how to fix that. F of x is equal to a is 1 times x minus negative 13 over 2. See, that plus 13 over 2 is changed to minus negative 13 over 2, so that negative of negative becomes positive. Whole square plus 31 over 4. Okay, so we have now your a is equal to 1, x and x same, minus sign is matching, h equal to negative 13 over 2, and k is equal to 31 over 4. So even though fractions are involved in this problem, still the whole process is the same. We just have to be extra careful. Sometimes we, like I did over 2, we'll end up some silly mistakes, right? Anyway, a is equal to 1, h equal to negative 13 over 2, and k is equal to 31 over 4. That gives me vertex, which is h comma k, that is negative 13 over 2 comma 31 over 4, and axis of symmetry AOS is the value of h, so x is equal to negative 13 over 2. In fact, you can verify this by drawing the graph. On any online graphic utility, you can just draw the graph and you will find that the vertex is exactly at this point, and the axis of symmetry, that vertical line, will be passing through this point, negative 13 over 2, right? So after following all these examples, please try these 3 problems which are similar to the ones we discussed just now. First problem is f of x equal to x square plus 2x plus 5. Then you have f of x equal to x square minus 12x plus 25. And the third one, f of x equal to x square plus 15x plus 65. Each of these 3 examples are similar to the 3 examples we worked out just now. Please try. Of course, you have to find the vertex and axis of symmetry. Okay, thank you. Thanks for watching.